This jet is traveling with a uniform motion. What does that mean? It means two things. One, that the jet is traveling in a straight line. And two, that the speed of the jet isn't changing. Let's see if this car is traveling with a uniform motion. Is it moving in a straight line? Yes, it seems to be. Is it traveling at a speed that doesn't change? Yes, it is. The car is moving in a straight line, and it's moving at an unchanging speed. That means it's moving with a uniform motion. What if the car continues traveling with this uniform motion for several hours? How far will it go each hour? Well, it seems logical to think that it should travel 60 miles every hour. When an object is traveling with a uniform motion, it travels equal distances in equal times. In this case, 60 miles each hour. We can prove that. This is a bag of chalk dust. The chalk bag will hit the road once every time the wheel makes a complete turn. So the distance between chalk marks is the distance the car travels each time the wheel makes a complete turn. If we measure between the chalk marks, we find that every time the wheel turns around once, the car travels the same distance. Now we substitute a light for the bag of chalk dust. Every time the light hits its lowest point, the wheel has made a complete turn. That means that the car travels the same distance between every two successive low points of the light. The speed is holding steady. And the car is traveling in a straight line. That means that it's traveling with a uniform motion. And that should mean that it's traveling equal distances in equal times. Is it? You can tell by the rhythm that each turn of the wheel takes the same amount of time. And we've already seen that each turn of the wheel measures off an equal distance. So the car is traveling equal distances in equal times. You can check that for yourself by watching the dotted lines go by. These lines are painted on the highway equal distances apart. They're going by at a regular rhythm. The car is traveling with a uniform motion. An object traveling with a uniform motion travels equal distances in equal times. Why is it important to know about uniform motion? It's important because the natural way for an object to move is with a uniform motion. For example, this rocket is traveling with a uniform motion. As a matter of fact, the men guiding this rocket could make it travel in a straight line, moving at an almost unchanging speed for years and years without ever turning the motor on again. That may be hard to believe, but we can prove that it's true. To start an object moving, you need a force, a push, for instance. On the other hand, once an object is moving, it has a tendency to keep moving. In fact, once you're moving, it's sometimes hard to stop. But The curious thing is that even if you hadn't run into the gentleman, eventually you would have slowed down and stopped anyhow. Now, just as it takes a force to start an object moving, it also takes a force to slow a moving object down. What force is slowing you down now? The car will stay motionless until some force moves it. The force of the motor is moving the car now. Now the motor is no longer supplying a force to make the car move, but the car continues moving. Why? Because a moving object has a tendency to keep moving, even if a force is no longer pushing it. But eventually the moving object does stop. Why? A force stops it. That force is friction. This surface is covered with sandpaper. The bottom of the wooden block is also covered with sandpaper. A force starts the wooden block moving, but it doesn't move far. It's stopped by friction. The friction is caused because the two surfaces are rough. As one surface moves past the other, the rough parts hit against each other. Here's a polished metal weight. It's so smooth you can see your face in it. This surface is also polished metal. What stopped the weight? Friction? These two surfaces are polished smooth. How could there be friction between them? This is the surface of a polished piece of metal seen through a microscope. It's far from smooth. There are no surfaces so smooth that there won't be some friction if they are rubbed together. We can reduce friction by lubrication. This is a lubricating oil. It moves farther, but still friction stops it. Here are two smooth surfaces, plastic and polished wood. But they're not so smooth that there's no friction between them. With the balloon added, there seems to be much less friction between the plastic and the wood. Air from the balloon is coming out of this hole. The plastic disc is actually resting on a thin cushion of this air. See how easy it is to slide a piece of paper in and out? The air doesn't make the disc move, but it does provide lubrication. There will be very little friction now between the plastic disc and the surface of the bowling alley. How does an object move when there is very little friction to slow it down? It moves in a straight line and with a fairly steady speed. It moves, in other words, with an almost uniform motion. Until there is a force to stop it. A human cannonball is a moving object, but he doesn't travel with a uniform motion. First of all, he's slowed down by friction with the air. And he doesn't travel in a straight line either. That's because the force of gravity is constantly pulling him down towards the Earth. What would happen to the human cannonball if there were no friction and no gravity on Earth? If there were no friction with the air to slow him down, and if there were no gravity to pull him towards the Earth, he would travel in a straight line at an unchanging speed. That is to say, he would travel with uniform motion. What happens to the rocket when the engine is turned off? Now there's no force pushing on the rocket making it go forward. But like all moving objects, the rocket tends to continue moving. And out here, there's almost nothing to slow it down or cause it to change its direction. There's practically no atmosphere to rub against and cause friction. And there's not enough gravity to pull hard enough on the rocket to force it to change its direction. And so the rocket continues moving ahead with an almost uniform motion. The energy of the rocket motor is used to produce force to push the rocket up against friction with the Earth's atmosphere and up against the force of the Earth's gravity. Once the rocket is free from friction with air and relatively free of the pull of gravity, the motor can be shut off. And the rocket will continue to travel with a uniform motion for millions of miles. It will keep coasting like that until it meets some force that slows it down.